questions with you again as a review for you, and then you're going to need to do those questions on 143, and then I'm going to do one more section here on Newton's third law. Okay, so let's look at sample 3. A 40-kilogram wind sled is gliding across a frozen lake with a constant velocity of 12 meters per second to the east. Okay, so constant velocity 12 meters per second east. When a gust of wind from the southwest, so what direction is it going? Northeast, right? So that's northeast. And what's the speed of the wind or the velocity? Doesn't say the velocity of it?
Constant.
Yeah. Okay. Exerts a constant force of 100 newtons. Okay, so that's changed things a little bit.
Oh, that's 100.
That's okay. I asked you for velocity and you gave us a force.
Just 100 north or something.
And it sails for 3 seconds. So the time it's sailing for. So we're really mixing this all up right now. A little bit of everything here. With what velocity will the sled be moving after the wind has subsided? Assume that there are no frictional forces in any direction. Okay. So we want to find out what the velocity is of the sled after the wind has gusted. All right? Right now, all I have is a force. I have this force right here. So what is it that I can find in order to help me solve this question? I need to find the acceleration. Okay, and we know the direction of the acceleration is also this here. So how do I find the acceleration then?
Force divided by your weight.
Force divided by mass. So 100 newtons divided by the mass of it, which is
40 kilograms.
40 kilograms, right? So that works out to 2.5 meters per second squared is your acceleration. Agreed? All right. Okay. So now, what I also can find is my change in velocity, because that vector is what's going to change it. All right, you're changing your velocity. So you're changing your velocity is 2.5 meters per second squared divided by 3 seconds. Is that right? I think I've got something wrong there. Sorry, it's multiplied. Acceleration times time. So 2.5 meters per second squared times my time of 3 seconds. So what is the change in velocity of this guy? 7.5 meters per second. And what direction is it going? Northeast. Yeah, because it's all of this force right here, right? Okay. So we remember this from the last unit. Change in velocity is equal to v2 minus v1. Agreed?
Yeah.
So my v2 then is equal to what? Change in velocity plus v1, right? I would add the v1 to the other side. Agreed? If I'm subtracting it, I'm going to add it to the other side. Yes? We okay? We got to follow this. So like I said, this question is terribly mixed up. All right? Because we're jumping all over the board here. Okay. So then if that's the case, I'm going to draw my change in velocity vector first. That's that guy, right? So that is 7.5 meters per second. Then I'm going to add on my other vector, my v1, right?
12 meters per second.
Okay, which is 12 meters per second to the east. And this right here would be my v2. Okay? So, what we had done in the past is we know that change of velocity is v2 equals v2 minus v1, right? The only change that we have to do here is, again, how do we draw our vectors? Because they're not acting in the same direction. So if something started out at 12 meters per second and accelerated 7.5 meters per second squared in the exact same direction, you would just add it on, right? Or add on 7.5 meters per second over the 3 seconds. But in this case, we have to use our diagram to draw this. So this is V2 net. This angle here is 135 degrees.
How do you get?
Northeast is 45, right?
Oh,
So 45 and 45, right? This is 45 here, that makes this 45 right here.
okay, wait, what was?
Okay.
That's,
Okay, so let me just draw this different. Let me put this on a different page. So if I draw it like this, right? That's northeast, agreed?
yeah, that's 45 right there.
That's 45 right there.
Yeah.
Which makes that 45 right here.
Oh,
Which also makes that 45 right here, right? Yeah.
did you say 35?
Okay, but then this is a right angle.
That's 90.
That's 90.
90 and 45.
Are you following? My next vector that I draw is this one, right there. So, and it's directly east. Okay? This angle and this angle are the same. Yeah? This angle and this angle add to give you 90.
Yeah.
So it makes this 45. This is 90 degrees right here. 90 and 45 make 135.
Okay.
All right? So let's go back to this. Using my law of cosines then. So square root 7.5 squared plus 12 squared minus 2 times 12 times 7.5. What do we get there?
18.098. Use the cosine law.
Law of cosines. 7.5 squared plus 12 squared minus 2 times 7.5 times 12 times the cos of 135, and then square root it.
We got that one written down. Yep.
Okay? So far so good. I would then have to find this angle right here. We know again that angle is 45 degrees. So let's find that angle there. So I'm going to go sine alpha. Again, I'm all over the board on this one. I don't much like this question because I have to move all over, but that's just life. Sine 135 over 18.098. What does that angle equal?
27.960.
27.960 degrees.
Yeah.
Okay. So then the direction then is north, right? And then it would be all of that angle right there.
Oh, so 72.96.
Okay. And there's your solution for that question. All right. So
How come you have to do like that side too? Like the 45? How come you have to add that on? Like, does the question say from?
because I want to know this direction that they're going right now, right?
And that's all.
And I only know the angle between here and here.
Okay.
Oh, you know.
So I could have subtracted. I could have gone east and then subtracted that from 45 to get this angle. And that would have been the complement of that, 18 degrees.
Okay.
But you have to pick either one side or the other. You can't
Yes.
just leave it like that. Then you're not going in a specific direction.
Because the sled is going this way to begin with. Or sorry, the wind is blowing that way, okay? And the sled's going east. So I need to know, when I combine the wind with the sled, I need to know which way they're going to go. Okay? All right, now that's probably the most complicated question you'll see in this section, to be honest with you. All right? We okay with this?
You don't-
Again, it's the same thing. The only thing I had to do different is I had to start with the force to get the acceleration, and from the acceleration I could get my change in velocity. So force, again, acceleration is force divided by mass. That's the only thing that's new to us in chapter 4. we've done these questions already. We did these questions in the last section.
Change in velocity and
Thank you.
acceleration.
Goodness,
Yes.
walking.
Okay, look at page 145. I'm going to go through Newton's third law. Probably the most famous of his laws are the ones that you would have heard of. For every reaction, there is an equal and opposite reaction. So that means if I push on the board here, the board's pushing back on me. I'm currently standing on the floor. I'm pushing down due to gravity. Floor is pushing up. For every action, there's an equal and opposite reaction. So what happens here, though, is what they want you to decipher is what happens if you have, example, a train, let's say. And I have to pull 2 cars with the train. Here's my engine right here. I'll draw it a little bit bigger. Okay? So what they want you to figure out is that the amount of force on this right here, I'll call it force 1, is not the same as the amount of force on force 2. Okay? Now how come? Well, this engine's doing all the work right here. This is the engine here. Smoke coming out of it. Okay? This engine's doing all the work here, right? So it's pulling on here both of those masses. Agreed? But this guy isn't pulling the F2. The F2 is actually pulling what we refer to as F3 here, mass 3. It's only pulling that. So this force right here is going to be less than that force there because it's pulling less mass. Now because they're joined, now think about it. A train is accelerating from stop. It stops at the tracks in town and it takes off to go to wherever it's got to go and it starts accelerating. Well, the acceleration of the engine is the same as the acceleration of the first car behind the engine, as it is the same as the 100th car behind the engine. The acceleration is going to be the same. They are linked together. But the amount of force on the couple on the coupler on the first, between the engine and the first car, is not the same as the amount of force on the last 2 cars between them on the coupler, right? And it's all based on mass. That's all there is to it. Okay? So take a look in the book here, and we'll just look at an example of this. A pull toy consists of 3 carts joined together by 2 short strings and with a longer string. If a child pulls the toy with a horizontal force of 6 newtons, what force must each of the short strings be able to withstand? Okay, so cart 3 has a mass of how much? 1 kg. Cart 2 has a mass of 1.5 kg. Cart 3 has a mass of
0.5 kilograms.
0.5 kg. And this guy, this boy, is pulling with a force of 6 newtons. Everybody okay so far? So if I were to ask you, which they have, they want to find out the force here and the force here, right? But if I were to ask you, how do I find net force? What's the equation for finding net force? Mass times acceleration. So what is it that I need in this question in order to find those individual forces? The acceleration. And if this is my total force here, my force is 6 newtons. 6 divided by, how come 3?
That's all the carts out and off.
Mass is 3 kg,
2 meters per second.
2 meters per second squared. All right. If I want to find the force right here of F2, what mass is being pulled? 1 kg. What's the acceleration of it? 2 meters per second squared. What's the force on that guy?
2 meters per second. Oh, 2 newtons.
2 newtons.
How do you do the 2 newtons?
Acceleration times mass. Like the 2 times the 1?
This times this. Okay? F1. How much is it pulling?
1.5. No, yeah, maybe. 0.5.
Oh, 2.5.
2.5 kg.
Oh.
I did that.
And what's its acceleration? 2 meters per second squared. So what's the force on that guy? 5 newtons. That's all there is to it. Okay. Yeah, that's it. That's all you need to know. All right. All right. Take a look at page 138, please. You were asked to do question 4 on your own. You did the other 4 questions as a group, correct?
We kind of like did them and then we went over them together.
A bullet of mass, 20 grams. All right, so my mass is what?
20 grams.
20 grams, but what do I have to have it in?
Kilograms.
Kilograms. So how do I change it to kilograms?
0.02.
0.02 kg. You got it right. You got it right. Divide by 1,000. Okay.
What question is this?
Question
4. Strikes a block of wood at a speed of 320 meters per second. So my initial velocity of this guy is 320 meters per second. The bullet embeds itself in the block of wood, penetrating to a depth of 6 centimeters. Okay. So it goes into the wood 0.06 meters deep. So far, so good. What is the V2 on this guy? 0. Embeds itself into the piece of wood and then stops. The question asks, calculate the average net force. So how do I find net force? Mass times acceleration. Out of those 3, what do I know so far? I know my mass. What's my mass?
0.02 kilograms.
0.02 kg, right? Oh. Write that again a little bit better.
You have to be working in kilograms. Like I mean, I am, but you can't work in grams.
Nope. All right. So far, so good. So what do you think I have to find from the other bit of information that I have there? Find my acceleration. Well, I have V1, I have V2, and I have D. How do I calculate my acceleration?
Which one?
5.
Third one? It's the 5th one.
It's the only one that does not have time in it.
5th one.
Oh, we have to
Fifth
follow
one.
that.
V1 squared.
Like the other formulas were like kinematics.
Yeah.
8 times D.
That's right. Very good. Okay, so far, we all remember this, right? Right, Amron?
Sure.
Okay, I gotta solve for A. V2 squared minus V1 squared over 2 times D. All right, V2 is squared is 0. So I go subtract 320 squared, and I gotta divide that by 0.12.
That's going to be a big number.
Sure is, yeah.
853,333.33.
Okay, and that's meters per second squared, and a negative.
Yeah.
Do I need that negative there?
Yes.
Yeah, because it's telling me what? It's decelerating. Well, is that bullet slowing down or stopping? Right. So now what do I do with this big number right here?
5 by 0.02.
Boy, multiply by 0.02, and what do I get?
Negative 1.7 times 10 to the power 4.
Let's do a little better than that. It's right, but I just wanted...
17,066. Like extrapolate it or
1.7 times 10
Get a better
to the
decimal.
power
But I don't want you to look in the book, because it's rounded all the time. So just take that number, 853,333.3. You got it on your calculator, right?
Yeah.
Times it by 0.02.
one, well, it's a big number, that's negative.
No, it shouldn't be that big. It should be smaller than 853. What do you got? Chris?
Negative 17,066 decimal 666.
6, 7, repeat. There's your answer. Okay? You give me 1.71 or whatever, then you're still missing by 40. 34 actually, but so you don't want to round things off, especially when you have it on your screen. You just get times by 0.02. Give me the whole number, okay? All right? That was an easy question, correct? Yes. Yes.
Yeah,
All right.
5 is a good one.
5. Did you guys ever figure that one out?
Oh, yeah.
Foster did it on the board.
Oh,
That's what
that
I couldn't
That was
read
one
it.
question,
I
yeah.
couldn't read the chicken scratch though.
I just,
Yeah, you should
I
do
blocked
that
that all
with
out because I was not understanding a single thing.
Okay.
I have a question. We can
Let's look at it.
Is there force applied equal to acceleration?
Now there's so much.
If it's in the same
If
direction,
it's in the same direction.
yes. Well, you take your mass and times it by acceleration, and that's your force applied. Yes.
Wait, are we gonna need force applied?
No. Oh yeah. Like in every question has force applied. Like that's the force that moves anything,
Oh.
right? So that is your force applied.
Your acceleration times mass is your force net,
That's correct.
but your force applied is not equal to your force net, right?
If there's no friction, it is.
Okay, yes,
If there's friction, then you would have to subtract the friction.
right.
So you get your applied force times your mass, or mass times acceleration, and then subtract your friction, and then that gives you your net force. Okay? All right, let's have a look at it. 0.5 kilogram skateboard is at rest on a rough, level floor in which two lines have been drawn 1 meter apart. Constant horizontal force is applied to the skateboard at the beginning of the interval and is removed at the end. Skateboard takes 8.5 seconds to travel the 1 meter distance and then coasts for another 1.25 meters before coming to rest. Calculate the force applied to the skateboard and also the constant frictional force opposing its motion. Okay, so you guys remember the duck question, right? And the rabbit question, you know, where you had just two parts. It's not as hard as that. It's much easier than that question. But you remember that there was 2 parts to it, right? Okay. In this part right here, let's just talk about our net force. So what's happening here is skateboard's on the floor. I stand on the skateboard, I push off on the skateboard, and I keep pushing for 1 meter. So what am I applying to that skateboard? Force. I'm applying an applied force. What's holding me back?
Friction.
Frictional force. Okay, perfect. So in the first part, I have an applied force and I have a frictional force. You agree?
Mhm.
All right. But I stop and I put my other foot back up on the skateboard and then I glide at that point. Okay? So at that point then, is there any more applied force being placed on that skateboard?
No.
No. So what is the only force being applied to that? Friction. Friction. Well, gravity is, but it's canceled by the normal force of the ground, right? Okay? But the force of friction, all right, is acting on it, and that's it. So, in other words, my net force here is equal to my force of friction. We get that? So for the first meter, I'm applying a force, and then I glide until I come to a stop. Yes, sir.
And that force is equal to negative force of friction.
Yeah, you can, sure. It'll be, the force of friction will be a negative, that's correct.
Yeah.
Because it's going to slow it down, okay? So far, so good? All right. So, here we go. I start from rest here, right? That first section's 1 meter, correct?
Yeah.
Does it tell me how long I apply that force for?
8.5 seconds.
8.5 seconds. So this is the information I have for this guy. Okay? Then I have B1 here. B2, oops. I'll put my A in here too. I'm going to need it. B2 is 0 meters per second.
He's not moving very quick, is he?
We pushed off for only 1 meter.
Yeah.
So you just like one kick and then
I
that's it.
went this far by pushing. So you kick this foot one time, right? Okay, so D, what's my D in that second part?
1.25 meters.
1.25 meters. Okay, so from what I have been given in that first part, what are some of the things I can find?
Your V2 would be your V1 in your second.
Yeah, that's right.
Acceleration.
But, okay, so what should be the first thing I'm going to find here? Let's find
Acceleration.
my acceleration here. Okay, I should find that. But, you know what, let's leave it for 1 second because I'm going to use that after.
He's not very.
Let's get my V2 first. Find my V2, please.
0.0.
So that's the one that we never use very often, where you have your average velocity. Okay? So find out how fast he's going first. Find your V2. Got her?
How do you even do that again?
Yeah, which formula are you using?
2.
Number 2.
Okay, so I have
That's on, oh.
delta D equals V1 plus V2 over 2 times delta T, right?
Okay.
I can see your V2.
69.
Yeah.
Sorry?
I can see your V2.
It will have to in this case because my V1 is 0, right? So what I have, let's just put in numbers now. I've got 1 here. I've got 0 plus V2 over 2 times my time, which was 8.5. So I'm going to times the 2 up to here, and I'm going to divide by 8.5.
Oh, so 1 times 2 divided by.
Yeah, that's right. And then divide by 8.5. Go
So
ahead.
not very fast.
0.235.
0.235 meters per second. Okay, so far. So that is this guy right here. Now what I want to find is my A in this one. Okay? And I'll explain that to you in 1 second.
We don't need to find like the V2 and the other.
I'm going back. Oh, this was V2 here.
Or I mean, next.
Yeah, we are going to find the acceleration in a second. But I'm going to work from this guy back, and I'll show you why. Because what I need actually, let me explain that right now. I'm looking for this. It's asking you what was the applied force. How much force did you kick with?
Okay.
Fair enough?
Yeah.
But in order to get that, I need the net force, which requires acceleration, which we can get. But I got to find the force of friction,
And that's in the second one.
and that's in the second one. Okay? So now, we've got this information here, so I'm going to take 0.235 squared. Okay, first of all, V2 squared equals V1 squared plus 2AD. Okay? I got V1, I got V2, and I got D. Equation 5. We all follow? I'm not writing it out. Let's see. Oh, maybe as well. What the heck?
V1, V2 squared equals.
Okay, so I've got V2 squared equals V1 squared plus 2AD, right? And my V2 is 0. My V1 is 0.235 squared. 0.235 squared plus 2 times my A times my distance of 1.25. So you're going to square that guy and divide by 2.5.
Divide by.
What was it, 2.5?
2.5. 2 times 1.25 is 2.5. So that value divided by 2.5.
Oh, I have.
What do you get?
0.2209.
Louder.
0.02209.
2209?
Yeah.
Okay. Just like that, okay? So far so good?
No.
It is negative, yes.
So do you
Because
divide
I'll tell you why. Just hold on. Let me explain this. First
You're
of all,
slowing down though.
you're slowing down. There's your first indication, right? You're coming to a stop. So you're going to have to slow down to do that. Mathematically speaking, Austin, watch. Subtract that to this side.
Right.
that becomes a negative. And then divide, so it stays as negative. So 5. Okay? So far, so good? Now, so everybody follows that. Oh, I'm going to write that down first. 0.02209. Okay, then I'm going to go back to this guy. Oh, I want that, I want that. All right, so now what am I going to find? Because I have the acceleration here now, what am I going to find here? I could find
Your
time.
net force.
I'm going to find my net force,
Which is
which
your force of friction.
is my force of friction,
So how do you find that?
Mass and
So-
acceleration.
Oh yeah.
right? So it's times that guy by its mass. So take that value, times it by the mass, and give me what the force of friction is.
What's the mass?
Yeah. What is the mass? Sorry, you're right. Good question. 0.5 kg.
Negative 0.011.
0.11?
Yeah.
0.45 if you really want.
Yeah.
0.45 if you want.
0.45.
0.45. Just like that?
Yeah.
Thanks, guys. Okay, there we have it. Okay.
So then you just-
So now I'm going to find the acceleration in this part using only the green.
You don't need V2, right?
I don't want V2 anymore yet. Don't need it anymore. I have my information that's given. So using the green, I've got V1, time, D, and I'm looking for A. Which equation?
Number.
3. Delta D equals, so I'll go across, let me go to a different page here. Delta D equals V1 delta T plus 1/2 A delta T squared, right? Okay, my distance in the first part was 1 meter. This was all 0. I got 1/2 times A, and my time in the first part was 8.5, and I'm going to square it. Okay? Questions?
You crossed out that first part?
Yeah, what
Because
the?
it was 0.
V1, 0.
0 times whatever
Yeah.
0.
0 times T,
Oh,
0.
Yeah, I did, yeah.
Okay. 0 times 8.5 is 0. Okay, good question though.
I was just looking.
All right, so what does my acceleration equal? Well, I have to take 1, and I have to divide it by whatever half of 8.5 squared is. So take 1 and divide it by half of whatever 8.5 squared is.
0.2353.
How do you figure this out? Would you do 8.5 squared?
No, 8.5 divided by 2.
8.5 squared divided by 2.
All
Did you square it? Yeah, because this should have been, that's almost identical to what we had in the next.
36, yeah. How's that work?
0.0.
Okay, so 8.5 squared divided by 2 is what?
36.125.
Okay, take 1 divided by that value.
0.0277.
0277?
Yeah.
Okay, so I take half of 8.5 squared, and I divide it into 1. So I get that value. So that is 0.0277 meters per second squared. And now, my last step in this then is my mass is 0.5, my acceleration is 0.0277 is equal to Fa minus the force of friction, which we found out to be was this value here, 0.011045 newtons. So my Fa equals
0.127.
this guy added to that guy.
Well, added.
So take 0.5 times 0.0277 and then add it to this.
0.539.
Okay? I'm gonna go different than the book.
Yeah, that's not
Yeah,
what
that's
I
not
mean.
right. That's not what I
That
got.
ain't right. You see that? You gotta get that up.
I got 0.0.02.
Yeah, that's
Zero
exactly what I
point
have
zero
too.
point.
0.02.
Divide that by 2,
485.
man. Divide whatever that was by 2.
489.
Go ahead. Sorry.
0.02485.
Still not the right answer.
0.00280.
I think we have double what we're supposed to.
You guys screwed up somewhere.
So we made an error somewhere along the way.
Why do we have double?
Because it's 1.2.
Oh wait, no, I see what I did wrong.
Yeah.
I didn't multiply those two. I added them.
Yeah, I
Oh.
don't.
It's 0.0249.
Okay.
That's what I did.
Okay.
I didn't see it.
All right.
I didn't even see
Okay.
that there.
Problem with this question is numbers are, because you've got so many small decimal numbers, it creates a lot more grief. Yeah, caution.
Whatever, you weren't doing anything.
The 1.2 is the positive fraction and the 2.6 is the positive.
Oh, I see. Okay, I wasn't looking at anything. Yeah, so we're good. Thanks. Okay, so let's go back and let's just quickly review how this is similar to something we've done. All right, again, the net forces part is what we just learned. That's all last week's work. This other part right here is all work that we've done. We've worked questions in stages. Stages, 2 stages or 3 stages, right? So we know that, what do we have to do here? We had to take the V2 from here and make it the V1 up here. We've done that before, right? Parachute question. When the motorcycle catches up to the other guy, right? We have to use the value from here and put it up there. Okay? We use that information in order to get my acceleration. The reason I want acceleration is because that's what net force works in, mass and acceleration. So that's what we do. All right, and then we worked our way back in order to get the force applied here because we needed this acceleration as well. Had you gone through and done all of this information and then just simply applied V2 here and got to there, you'd have most of the question right. It would have been just applying force net after that. Okay? All right, and the other 4 questions that you did as a group, or the 3 questions, I guess, you're comfortable with today?
Yeah.
Okay, I just want you to look at question 2 on 143.
We did those ones too.
Oh, I got a note that says you didn't
Not
start them.
those.
I thought we were still sitting for homework. So
When you guys were doing those ones, I was doing.
Okay, just have a look at question 2. It says forces 2 newtons and 1 newton act on an object of a mass 5 kg as shown in the diagram. 99% of the time you're going to draw that one wrong. Okay? It's shown in the margin, but what's the problem with the one in the margin? Yeah, what part of it's wrong? Yes, the tip to tail part is exactly correct, Amber. All right? It should have been, it's right now it's tail to tail, right? No. So we have to draw our 2 newtons, okay? That's this force right here. And instead of drawing this guy right here, I move him over to here and put it there. Now that's right. So that gives me my net force right here. All right? So I'm just telling you this in advance so that you don't make the same error. So then instead of this being 120, this now becomes 60 degrees right here. Or 60 right here, whichever you want. Okay? So that's just to help you solve that second question. The other 4 questions I don't think are going to cause you too much grief. You're adding vectors in the first one. The second one has an angle on it, so you're pulling a train with an angle. Now remember, this force on the handle of that train or on whatever's pulling it, right? This applied force is down here. But the force that they want on is that handle up there. So you got to remember, they draw an angle for it. It tells you it's 25 degrees. Okay. All right, so I'm just helping you a little bit here. The third one has the incline. Okay, the fourth one has the incline. So you have a mass going down the hill. So you got to remember your triangle. What are the forces acting on this? Let's review this.
Applied.
Okay, which direction is the applied going?
Down.
Okay. Oh, okay.
Oh yeah, southwest.
Stay parallel to the slope.
Yeah.
Right? So your applied would go that direction, right?
And then direction would either be
Okay. Works which way?
the opposite way because it's sliding over.
Right. So your force of friction be that way, Jason?
Gravity.
Gravity's working which way? Okay.
Perpendicular to the ground.
Perpendicular to the ground, right?
And then there's a normal force.
Okay, so then the normal force, and what's the normal force acting?
I'm not
Perpendicular to the object.
Perpendicular to the slope.
There you go.
Okay, it makes a right angle with the slope. So now what I do is I draw this down here. This guy is parallel to that, is parallel to that. So that means then that this guy right here is your applied force. Okay? This guy right here is your normal force. This is a right angle triangle now.
Yeah.
And your force of gravity is your hypotenuse. Okay? So you use that information. This angle they give you in the slope is that angle right there. So remember what I did the other day? I drew it out like this. Force applied. Oops, that's not a. Force applied. Force normal. Force of gravity. All I did was rotate this and stick it there so I can see it easier. This angle right here, what's the angle of that slope? What is it in that question for?
15 degrees.
15 degrees? So that's 15 degrees. So you can find all your information using that. Okay? Force net equals force applied minus force of friction. And if you want, mass times accelerations applied minus friction. Okay?
So
So you got questions on 143 and 147, and then we're into a review. This is a super short section which you can get a really good mark if you're doing these questions. I sometimes combine this with 5, but I'm going to give you an opportunity to do a better job of this test right now. Yeah.
So
I haven't. I'm going to do them right now, actually.
so your force of gravity would be equal to 9.8 meters per second.
No. Say yes. Yeah, sorry, you were right. By the maths.
So you can use the right angle to the center.
Yeah. Okay, so you have questions on 143 and 147. Those need to be done for tomorrow. That's 9 questions. Okay, so get at those right now, please. All right. Anybody need a book?
Me. Mine is like destroyed.
Tell them to invest in some new ones.
Well, I've looked at them online. I can't get them at the